Hello everyone, I'm James and welcome to episode 11 of the OpenGL tutorial series. Today we're adding a skybox to our scene. A skybox is very simple. All it is a cube and with texture each face with a different texture. This is the difference from what we did in a previous video where we textured the cube with the same texture on each face. How can we achieve different textures on different faces? This is where cube maps come in. Cube maps are amazing. They're 3D textures that have 6 faces, just like we need. And all we need to do to sample them is sample with using the position. To understand better, let's go ahead and implement.
The first thing we'll do is add a static function in the texture class to load the cube map from 6 images. So the function will take in 6 file names of the 6 images we want. I'll add this image class. All it does is loads an image with stb image and stores info about it. This will be useful as you will see soon. In the load cube map definition, we'll start by creating an array of pointers to images. Next we'll load the 6 images. Make sure you put the images in the same order I did. You will see soon. Now we'll create a texture and bind it. This time we are binding the texture to the texture cube map target. This is very important. Now we'll loop through each image. I'm only going to support RGB images, so I'll convert the RGBA images to RGB. Before we forget, let us delete the image at the end. And if the image is RGBA, we need to delete the pixels as well. Before we delete the images, we need to call glTextImage2D, so we'll be calling this for every face. The first parameter is interesting. We need to tell OpenGL which face we are going to set. These are the targets of the different faces. Rather conveniently, these constants are in ascending order, so we can just put glTextureCubeMap +x plus the I variable. The second parameter is the level, which we don't care about, so I will set to 0. The third parameter is the internal format. I'll set this to RGB8. The width and height are going to be the image width and height. The border we don't care about, so I'll set it to 0 as well. The format is going to be glRGB. The type is GL unsigned byte, and the final parameter is the pixels, so we'll pass the pixels pointer. At the end of the function, I'll set these parameters. The first 2 parameters tell OpenGL to use linear filtering for the textures. The 3 last parameters tell OpenGL to clamp the textures to the edge instead of tile them. This will prevent seams at the corner of the skybox. Finally, we are going to create a texture instance from the ID and the width and height, which we'll assume is the same for every face. Also, I forgot to store the width and height before deleting the images. Now we need to add a constructor in the texture that takes an ID and a width and a height. The implementation is very simple. We'll just initialize the fields appropriately. Now we need to create a vertex shader and a fragment shader for the skybox. These shaders are going to be very simple. In the vertex shader, we only care about one attribute, which is the vertex position. We need one uniform for the world view projection matrix. So what kind of texture coordinates are we going to use to sample the cube map? The amazing thing is we already have the texture coordinates, and they are stored in the position. Remember, cube maps are 3D textures, so the texture coordinates need to be 3D too. So we'll send out the position as a varying variable. The vertex shader's output will be the same like the diffuse vertex shader. The world view projection matrix multiplied by the vertex position. In the fragment shader, we'll take in the 3D texture coordinates. We'll also take in a uniform for the cube map. This will be of type sampler cube. All we need to do now is sample the cube map with the 3D texture coordinates and output the color. Now we need a new material type. I'll call it Skybox material. The only thing this material will contain is the cube map. We'll initialize the cube map in the constructor, and we'll also load the Skybox shaders for the material base class. In the update uniforms method, we'll first bind the cube map in slot 0. Then we'll set the cube map uniform to 0.
Okay, so I did a couple of things. First of all, I added these images that make the front, the bottom, the back, the left, the right and the top of the skybox. In the source code, I loaded this cube map right here. Then I created a cube, and then I created a sky material, which is made by a skybox material, and it takes in just the cube map. Then I created an entity with a default transformation, a cube and a sky material. There is another thing I want to show you. In the image header, I moved the constructor and destructor definitions to the source file, which is right here. This is the constructor and this is the destructor. Now, as you might notice, there's this line. Let's run and see what happens if we don't put this line. As you can see, we loaded the skybox. It's very small, and if we look inside, there's nothing. So we need to flip it eventually. But you might notice that everything is upside down. So that is why I was flipping it vertically. I'm not really sure why this is happening, because if I'm not mistaken, usually I didn't need to do this. But let's do it and see what happens. There, much better. The sun is at the top as it should be, and the sides are also, as you can see, they join pretty well with each other. Now let us make the cube map, let us make the skybox render from inside. So this requires us to do some other things. I'm going to store the entity, the skybox, as a field. And instead of calling create entity, I'll initialize the skybox to a new entity. And I'll pass in the same parameters, at least for now. So why did I do this? Well, now, because we created the entity here, it will not be stored in the entities list. What I want to do now is call skybox render. And the reason why I'm calling it separately is because of this parameter. Not this parameter, neither the light direction. So those are the same. The last parameter is the render inside. If you remember correctly, the render inside tells OpenGL if we want to enable face culling on the outside or on the inside. And by default we don't render the inside. I want that to be true this time. This time I want to render the inside. Now if we run, as you can see, the outside isn't being rendered and we're only seeing the inside. And look at that, we have a skybox. Obviously it's small, so all we have to do now is scale it up. And to do that it's very easy. Here in the transformation I'll set the position to 0, I won't be modifying. I'll set the quaternion to an identity as well, an identity quaternion. However, I'll set the scale to, let's say, 100. And now if we run, there you go. We have a skybox. Amazing. There are some other things I want to do. If I run right now and you look up, you can see that the sun is right there, but the lighting is coming from up here. So Let us rotate the skybox so that it's well facing the light. So to do that, it's actually very easy. All we have to do is, instead of passing this identity quaternion, I'll pass in angle axis, sorry. I'll rotate it 180 degrees, so I'll convert it to radians because it requires the rotation in radians. And as for the axis, I'll rotate on the y-axis, so 0, 1, 0. Now if we run, yeah, the light is coming from the sun now, which is perfect. There's another thing I want to do. I want the skybox to move with the camera. I don't want to be able to get closer to the sky like this. This doesn't make sense. I want to make it look infinitely big. And that's actually also very easy. All we have to do is go to our, not the render, sorry, the update. And I'm going to grab the skybox transformation. I'm going to grab the position and I'm going to set it to the camera position. And now if we run, yeah, the skybox is now moving with the camera, which is perfect. Awesome. And that, my friends, is the end of the video. In the next video, we're finally going to start working on the fabulous water. Can't wait. So, if you want to be notified when the next video is coming out, please consider subscribing to the channel and hitting the notification bell. With that, thanks for watching and goodbye.